we'll review both of them. Source, so this is actually like the meat of our MEV searcher here, where all of the logic happens, and everything except for the extraction on chain happens here. And then some tests that were written to ensure that the system's working as intended. Usually stuff happens in index, so that's where I've started here. Got a bunch of imports. Not that much here to note other than if you're interacting with Flashbots, there's this one repo called the Flashbots bundle provider, which is very special, and you'll need to import this always. And that just helps you submit and create bundles to send to the Flashbots relay. I guess that was some context that none of us shared. When you are an MEV searcher, you will be interacting with the Flashbots relay. This is like this middle point between searchers on one side and miners on the other. So you submit your bundles to the relay, we simulate them, and if they are profitable for the miner and they don't have any errors, then they get sent on to the miner. And this is necessary to prevent spam attacks today. Eventually we're going to obviate this. It'll be decentralized, but I won't go into those details. So returning here to our index file, bunch of imports, like stuff that we need to be able to interact with the chain as well as send transactions from ethers here, some ABIs of our contract, Uniswap pairs. A lot of the times you'll end up with a bunch of different addresses or ABIs that you need. And so Beef 12, the repo is simple. It's like Flashbots / simple arbitrage. If someone else could put that in the chat, that would be great. But it's pretty easy to find on our GitHub. Anyway, a lot of the times when you're making these things, you'll be interacting with a bunch of different addresses. And so it'll be useful just to create one file where you list all of your addresses. And you can import this single file and then get your addresses from there. Instead of like posting them in one place across like six files and then needing to do that for a bunch of different addresses. It's just like quality of life kind of thing you'll see a lot. So in this case, we're pulling different markets here that we're looking at, as well as the token we want to arbitrage, one part of it, and a contract we deploy. And then there's some variables here for things that we're going to need to make this work. You need a node, which is the Ethereum RPC URL. This is how you get data off of the Ethereum chain. You need a private key. I'm not going to be using mine, so no one will get that. Instead, I'm like this is a bad habit, but I'm just generating a random private key here for this purpose, for this stream. And then you need to deploy a contract actually before you use this. But since we're just like monitoring and talking about this, I used a random address that actually isn't the address of a contract here. You need another private key to identify yourself to the Flashbots relay. This can be anything. It doesn't need to be like what you're executing transactions with, just a private key to sign your bundles with so we know who you are. And yeah, that's how our permissionless authentication and identity works. You can change this. It doesn't really matter. This is a random thing. And then how much of your profits you're paying the miner. If you get into MEV searching, you'll be upset at how much profit you pay to the miner. Yeah, those are our environment variables here. Not too much to say. And we start this by setting up the things that we need in order to pull data off of the chain. So that is our static JSON RPC provider. This is how we will get information off the chain. We build up a wallet to sign our arbitrage transactions, and then a wallet to sign our bundles to Flashbots. So this wallet on 38 is what you use for your transactions. And then on 39, there's a separate wallet with a different private key that you use to identify yourself to the Flashbots relay, actually. Yeah, thanks for posting that, Scott. And to answer your question, Milky Shake, I think there's a lot of opportunity in other places. You will need to do things in a different way than we do here because you don't have Flashbots, but some of the other chains have lower barriers to entry, I think. Okay, so this is the actual like function of the code that's run now after we've imported everything. Start out by creating a Flashbots bundle provider. This is the thing that you use to actually create bundles and send them to the Flashbots relay. And again, that takes the thing we're using to provide data from the chain and our relay signing address. And then we create this object called arbitrage. It's its own class. So I'm going to double click into this and see what it is. Arbitrage takes a couple different things here. We have our Flashbots bundle provider to send bundles. We have a contract that we're interacting with, and then a wallet that'll be sending transactions. And all of these things get set right here in the constructor so that they can be referenced later. And then it looks like this has a bunch of functionality. Yeah, so this has a bunch of functionality to evaluate markets that we'll be trading on and then send transactions later. So there's two kind of important things here. The first is you're setting this up with some stuff that doesn't change. So the address that you send bundles with, or the private key rather, and then the Flashbots bundle provider and your contracts. You'll use that for every single transaction that you send, and these stay the same because they're input in the constructor. But then there's a bunch of other interesting functions here that will change according to each block that happens, and you'll input new data per block. So you construct this thing one time with your bundle executor contract, your Flashbots provider, and then your signing key, and then we will use this new arbitrage object to evaluate different markets and keep on pumping data into it for new blocks. Okay, so we'll return to what this actually does and the functions within it in a little bit. But going to go line by line here. So we have this constant markets equals await Uniswap v2 ETH pair, get Uniswap markets by token. That takes in our provider. So this is getting different, this is the thing that we use to pull data off of the chain, and then all of our factory addresses. So what does this do? Oh wow, we've got a bunch of people in here. I didn't even notice that. So welcome everybody. I'm excited that you're here. Hope you learn a lot, and feel free to ask questions. Okay, so what does this market thing do, and what does this Uniswap v2 ETH pair thing do? Let's check it out. So we're inputting the provider that gets us data, and then the factory addresses. This line takes all of our different factory addresses within our addresses file, and it in parallel will execute this call. So on Uniswap v2 ETH get Uniswap markets, we'll input each factory address into this function. So if you recall, we've got all of these. Okay, so here are our factory addresses, and then we'll plug each of these into this function here. So each of these is a different fork of Uniswap, or it's Uniswap itself. So I have no idea what this is, but CRO factory address, that's some Uniswap v2 fork. Zeus factory, no clue what it is. It's a Uniswap v2 fork though, as is Lua, and you all will know SushiSwap and Uniswap, I think. And then this will pump back the addresses for it. And the reason why this is useful is because within the Uniswap factory, Maybe I can do this. We'll go ahead and look at one of these. So within the Uniswap v2 factory for any of these, they have a function that lets us get pairs. Aha. I think this is what we're looking for. Yeah. So we first need to understand what markets we're looking for arbitrage opportunities on. And we have a bunch of these different factory addresses and like broad umbrellas of dexes. But the way that Uniswap v2 and v3 works is you have a factory contract that will deploy a bunch of little contracts that stand on their own. And those little contracts actually are what you are trading on, and it's where you can find prices of different assets, not the factory contract itself. But in order to perform arbitrage, in order to get data from any of these things to find opportunities, we then need to know where all the little contracts that have been deployed by the factory are. And so this step of the code is really about looking at the factory and asking it, where are all these little different pairs that you have created? And using that, we can then get their addresses. So I just plugged out one of them here. It's like some random pair if I click on it. So it's a stable coin in USDC2. If I do one, I think this is like ETH and DAI, if I recall correctly. And with these addresses, no, USDC and ETH rather. With these addresses, we can then pull data from these individual pairs to understand what prices are, and then later we can trade directly on them. So that's why we need the factories. That's sort of their purpose in here, is just to tell us where these pairs are. But the thing is that there are a huge number of pairs on Uniswap. At V2, I think it's like 30,000. Maybe Scott or Steph knows that off the top of their head, but it's a lot of different pairs. And you would just spend a huge amount of time if you sat here, or even in a programmatic way, and did like 0, 1, 2, finding all these addresses, like looking for the things that you want. And so one of the sweet tricks of this repo is, instead of doing these lookup functions one at a time, we do them in batches using this super cool contract that Scott made called Uniswap Query, Flash Query. You can see it here. We are calling the get pairs by index range function here on the Uniswap Flash Query function. So this takes in a Uniswap factory address, just like the one that we were looking at here. And then an index to start at and an index to stop at. And it will look at the full length of the Uniswap factory. And instead of going through and doing this one at a time and like returning this data to us one at a time, and then we go to the next one, this executes the same operation, but just in batches. So it returns all this data in batches for us, which is an extremely useful thing to do. And the reason for that is that when you're interacting with your node, it takes some time to get out data from your node, get it to your software, and then ingest it. And it takes some time to like take the command that you're giving your node, turn it into however the client understands it, and then return it. And so if you can, instead of doing things in a one-off, like many to many, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if you can just batch it all together, do 10 requests at one time, you can make things much quicker. And so this is a nice trick if you have a lot of data that you need to get off of the chain at one time. It's like, try to batch things together. I'm not flash loaning pairs right now. I'm just looking and trying to find them. Oh, yes, I am like sort of flash learning addresses. You are right, Igor. We get all of these different pairs by index ranges. And the other nice thing that this does is once we have the pair and its address, we wrap it inside of this Uniswap pair interface so that we know within our smart contract that we're interacting with a pair. And because we know that we're interacting with a pair, we can then call its functions. So here I'm interacting with the pair, and I call to see what the first token is, token 0, it's kind of confusing, and then what token 1 is, or the other pair. So this would be like USDC, and this would be WETH, or something similar. And then we construct this result object that has the address of the token, one token, the address of the other token, and the address of the pair. And through our whole loop, we do this for every single pair that's in like the Uniswap factory. And we return this structure that has all of the pairs as well as the tokens within those pairs. And so now we know we have like all 43,750 different pairs on Uniswap v3 or Uniswap v2, and we know which tokens that belong to each of the pairs, and we can start pulling data from them and interacting with them. And that's also a very useful thing because we don't care about all pairs, at least in this repo. We don't care about all of them. We just want we just want pairs that have WETH, that have ETH on one side of them and something else on the other side. And anything that's like ERC20 to ERC20, we just immediately throw away. Because in simple arbitrage, we're only looking at like WETH and DAI to DAI and WETH arbitrage trades. So okay, that was a lot. But this was the first step of like interacting with our query contract that makes it easier to get data off the chain in batches. And again, that makes it way faster and more simple to get this data off of the chain. We do that for all of our factories, and it returns like this pair's address, this pair format, which you saw here with a bunch of data of the tokens in there and then the pairs. And so the next step for us is taking this giant array that has been created, and we're just going to decompose this data now, getting for each of the pairs that have been returned, what's the pair address? For each of the pairs that have been returned, what is the address of the pair, which is the second thing, and then what are the tokens that are inside of it. And specifically, we're looking for tokens that have ETH in one side of them, or wrapped ETH, WETH. And if it does not have ETH inside of them, then we're just going to restart our loop. We're not going to do anything with that pair. But if it does, we perform one check to see if this is blacklisted for some reason. Maybe there's like a pair that acts really weird and you can never arbitrage it, but it screws up your bot. So you add it to a blacklist. But if it has ETH and it is not on the blacklist, we then create this object to help us interact with it. And we push it to a list of different markets that we're having that we will interact with. And yeah, so the end result of this, to reiterate, is we've looked at all these different factories, and using our query contract, we've gotten all of the different pairs that existed on them. We've narrowed them down to only things that have WETH or ETH inside of them. And then we have pushed them into this array called market pairs. I will try, Grug, to leave this up, but I'm not sure. I don't know. I haven't streamed before, so this is new to me. I will try to record it and make sure that you can view it. Gathias asks, why only WETH pairs? The reason is that we pay our costs in WETH. And it's very simple to pay your costs in what you make profit in. So if I start with 1 WETH and I end with 1.01 and I pay like 50% of that to the miner, then I know I've made pure profit and I don't need to handle like pricing risk over time if one asset rose or fell. And I don't need to think about what the profit of some other asset was at the time. I know that like that's strictly profitable in terms of ETH for me. But if this was instead DAI, and we were only arbitraging DAI pairs or something else, I would need to think about what is the relationship between WETH and DAI? Am I long DAI? Am I like inherently long DAI if I'm taking profit in DAI, but I'm paying costs in WETH? So you can do that. It's just more complicated. And as long as you're fine denominating your profit and loss in ETH, it makes more sense to just strictly arbitrage, to start and end in ETH. Yeah. All right. So we have all our markets. We know where we're getting data from. I think that all made sense, I hope. And yeah, let's return. I forget where I was. All right. So these are all our pairs, all of our markets that we're getting data from. Oh, and Steph had to go. Thanks for joining, Steph. Appreciate it. So here we're just like transforming this object to make it a little bit easier to interact with. We're telling where WETH is on this instance. Scott, you know TypeScript better than I do, so maybe you can talk about why this is useful here, if you're by your computer.
Wait, you're talking about which part? This chain?
Yeah, so 84 to 94, what are you doing here, and why is this useful?
This is just something called Lodash, which just allows you to kind of more in more of a flow, like extract bits of data without kind of creating a for loop and like adding values to the end of an array. It just sort of takes a bunch of these things and kind of makes it a little bit more like Pythonic, really. Kind of things kind of flow from one state to the other. So it's just a simple way to group things.
Yeah. And like functionally, you're looking for which of these, you're like assigning and knowing where the position of WETH is in these, right? And grouping them by that way. Is that right? I think that's right. And I think Scott also.
Yes. Yes, that is right.
Yeah. Okay, great. Yeah, so that makes it much easier for us to interact with, and nice tricks with Lodash here. So then, this is an important line. We have 96 here. We have all these different pairs, and we need to have continuous data for them every single block. And so we're going to update our reserves for those pairs. Like we've just structured these in a way that makes more sense. So we're ending up with this object, all market pairs here, and we pass it into update reserves along with our provider, which helps us get data. So update reserves looks again at the contract that we're using to batch our queries here. So Uniswap query, it will be familiar now if you're paying attention. We get that, then we make a simple object that has all the addresses of pairs that we're interacting with. And this should keep the same ordering of our market pair object as well. Just kind of for the console's sake, we print how many addresses we're looking at. And then this is where the actual magic happens here of getting data. So we create this object called reserves, which looks at our query function here. And we get reserves by pairs and plugs in all of our addresses in this large array here. So let's look at this. Okay. So again, it expects that you plug in an array of different addresses, and actually this is a Uniswap pair object, so you can just directly call call functions on this instead of reinitializing a pair. It's kind of useful. And then we're going to be returning a bunch of data here in batches because that's faster again. So we create this object that has a length according to the number of pairs, because our goal here is to return the reserves for each pairs. So the array should be the length of the number of pairs. So we'll have reserves for each. And then we loop over each of the pairs and we call this getReserves function on them. Maybe I can just like show you all what that looks like on a random pair. So I just like got a absolutely random pair. I don't know what this is. Literally, I have no idea, but it doesn't matter since it's a Uniswap pair. They're all the same. We're calling this function getReserves. So a reserve is the amount of token that exists in a pair. So if it's a Uniswap and DAI, then a reserve would be like the amount of uni token you have, or the amount of DAI, or the amount of ETH, or something like that. And then it also returns this block timestamp last, so when it was last interacted with, but that's not as useful for us. We're really looking for this reserve and this reserve, because those can be used to figure out the price of different assets. Let's return here. So we get result 0, that's like the first reserve, and then result 1, that is the second reserve, and then result 2 here is the timestamp that's included with these things. And you loop over each pair, and you do that for all of them. FMO Sturts asks, how would you get reserves /ticks/prices on V3? The answer is, I don't know. So let me know. I didn't spend the time figuring out V3 and like upgrading my searchers to that. It has more of a learning curve, and so it's much more difficult for a hobbyist to figure out and reason about. But I imagine that it's like fairly simple. Fairly similar to what this is, where there's a function that you can just get the reserve, or get the ticks rather, and then you'll need to reason about it in the same way that we do here, and it probably makes sense to get them in batches. So we go over each of our different pairs, and note that this is for all pairs across all the markets we're looking at. It's not just like Uniswap or SushiSwap. It's Uniswap and SushiSwap and any other factory addresses. And we get those, and we return them in like this giant array here called result. And then this step looks at, for each of the different markets that we had before, we're going to loop through those markets as well as our pairs, and we're now going to set the balances of the reserves internally, because that'll help us interact with it and pull data out later when we're like figuring out pricing and like how much to trade where and whatnot. So to double click on this section, this is actually maybe the most important part of this entire process, is how you get data off of the chain and how you structure it on your searcher. It's super important to have like all of the data that you need, and then to do as many calculations as possible off chain, and to do that in fast ways as well. That's why we're using batching. The reason why that's important is because Flashbots bundles are prioritized according to gas price. And so every single thing that you do on chain will lower your gas price and make your bundles less competitive according to someone else. If you can do your computation off chain and only input the minimum amount that you need into your functions and only do the minimum amount that you need on chain, then you will have more competitive bundles. And oftentimes, this is just more simple anyway. So this process of figuring out what data you need and how to get it and how to do it in a quick way is extremely important. And for some of the recent searches that I've written, this is the majority of the time that I've spent is actually on this process of getting data, figuring out what data I need, and how to structure my bot. And not only have the data, but store it in the right way and make sense of it. So super important. All right. Let's see. So we updated the reserves. And then what? So it looks like here we're doing another Lodash thing, which helps make it a little bit more Python-y. You could like sort of think of this like a mini layer 2 that does stateless computation. I mean, we're really, like all this computation could be done on chain, and it is done on chain regularly. It's just not necessary to do it. And if you can do it off chain, that makes you more competitive. Hey Tuba, thank you for joining. I am a huge Dota fan also. I was ranked 42 in the world for Terrorblade at one point. Just made my face a little bit larger as well. So I'm gonna like put that a little bit down. We got our reserves, we updated them, and then we do like this Lodash chain thing again, which just helps us sort our object in a way that makes sense. So for us, we're filtering by pairs that have a balance of ETH that is greater than this object ether. And if you click into this, we're looking for things that have a balance of higher than 1 ether. That's what this object is. So we only want to look at pairs that have more than 1 ether, because anything that has less than 1 ether, it probably doesn't have very much money in it, and there's not much money to be made. And so we don't want to spend time and computation on those things. So we're just going to filter them out. And then an important thing to also realize here is we're using Big Number, which is a library in ethers that helps handle really large numbers. So on chain, many numbers that you're interacting with are like 10 to the 10 times 10 to the 18th, or 321 times 10 to the 24th. These are extremely large, and oftentimes the languages that you're working with cannot handle them normally, and they'll like round up or do something funky. And so to get really precise variables, which we need precision. You want to be able to do it down to the single way. You need to use special libraries. And in particular, we're using this library called Big Number, which is really good at handling big numbers, as you might be able to tell. We filter by the things that, again, have greater than 1 ETH in them, and we return those as well as our market pairs. So let's come back. So actually, all of this happened in startup. None of that actually did anything in production. Like not a single block has passed. And I can run this for you all, and you can see what it is. I have like I have some stuff in my environment here, and then I'm just using random private keys for my addresses. Right now, this will not output anything for a couple seconds because we're running like this really, really large query to our smart contract doing this batch. So first, like in the background right now, it's just like crunching numbers, getting all these pairs by index and returning them from our node, and then it's going to get the reserves by pairs and return that too. So that should run. It'll like take a couple seconds to load up at the start because it's a really large computation, so it'll go on. And we are listening to a WebSocket here, I think, for the event of a new block. So every single block, you're going to want to return, you're going to want to update the state of these reserves and then like see if there are new arbitrage opportunities. So we watch for new block opportunities and we update the reserves in the way that you just saw that we did. This is like a pretty usual architecture if you're looking at the last state of the chain. For advanced bots, you will be watching the mempool for pending transactions, and that's like one big difference for other bots. But for simple things like this bot, it's fine to just watch for the next block. So we get all of our different reserves and we evaluate our markets here. This is where some of the action goes on. Oh, here we go. We have a result from our initial computation. So I just ran this script, and that entire time that we were waiting between when I ran it was like this part, literally, like only this, as well as the setup that was going on. So it takes a really long time to start, and then it'll take much less time going on after that. But since you need to get all the pairs, and that's doing like tens of thousands of different calls, it'll take like a long startup time. So what did that do? Like again, we got every single market across all those dexes, and then we narrowed it down to only 1,280 of them, because those are the only 1,280 different pairs that have both ETH and more than one ETH balance in them. So those are our conditions. We don't want to look at anything else. It's probably not profitable, or it's profitable in a way that we don't care about, like another token rather. And we'll get into it and like how we got these numbers, but it's actually like a very profitable block. Wow. So just randomly I ran this and it was 3.5 ETH worth of profit on a volume of 2. That like almost seems wrong. So something may have gone on there, or something wrong may have happened, but a good sign.
Yes. So what happened here is that there are scam tokens out there, and this thing does not filter out scams.
Oh, I see. Yeah. So like, would this have drained our bot, or is this?
No, we would just simulate it and be like, oh, that's not valid. Or even when we send it to the chain, it's going to ensure that it makes a profit. But just by looking at the reserves, it might think that there's something profitable when those tokens are not transferable at all.
I see. Yeah. Interesting. So I'm going to keep on going here. We evaluate our markets. And that performs the stuff that you're seeing in the console now, like figuring out what the profit is, as well as what volume you need to trade and where. So we take all of our markets here. I've been talking for a while. I feel like I'm going kind of slow, so I'll try to speed up. But let me know if I'm going too fast or too slow or whatever. We get all of our markets by our tokens, and we look at for each token in the market, we create for each token in these markets by tokens, we then get out a new object called markets. So what this is doing is it's like, we want both ETH as well as DAI, and we want to know all of the ETH and DAI markets. And by knowing all of the ETH and DAI markets, that like subsection of all of the markets together, the 4 or whatever there will be, we can then compare those against each other to understand what the price of selling tokens in is and what the price of, buying tokens is and selling tokens. So we create we filter down to one particular token that is trading against ETH, and then we figure out what you can buy that token at or sell that token at, which is kind of helpful for us. And we do that for each token besides ETH itself. If we know what price you can buy them at and what price you can sell them at, there's like this very simple heuristic of, can you sell the tokens at a greater price than you can buy them? Yeah. And I think this is taking 2 different markets from each of those and saying, like, on Uniswap, can I buy tokens at a better price than I can sell them on SushiSwap? And so you take both Uniswap and SushiSwap and you push these crossed markets where you have this price differential to this new object we're creating called crossed markets. So this is where we actually figure out if there's an arbitrage opportunity at all, or whether we should look at it. But we haven't priced it yet. We don't know how much to trade in. And then, now that we know which markets there's some kind of opportunity at, we can get the best cross market. So let's see, what does this do? We put in all of our different markets that are crossed here and their token addresses. So this is like every combination of Uniswap and SushiSwap and like Lua or whatever the other forks are for DAI. We're looking at what are the best crossed version of these. So if I was going to trade DAI, where would I trade it across all these markets? So we break these down to where we're selling and where we're buying. And there's this like super naive way of pricing these things. It makes me smile. God bless you, Scott, for making it this way. In production, you probably don't want to do this, but it works for just like a test case in naive. We have a couple different volumes of things that we can trade in. And this simple bot looks at each different size in this volume array and says, for this size, how much profit would I make by buying tokens on one market and selling them on another? So if I'm buying, 1/100th of an ETH on the first market, taking that output and selling it on the second market, how much profit would I make, if anything? And if there is no best market, and if it is less than the best market that we found thus far. Okay, so if we haven't found a best market so far, then we try to like optimize that a little bit more. If we have found a best market and the profit on the current volume is less than our best market's profit, then we try to optimize that a little bit more. So this is like just a little bit more volume to this. And actually, all of this code is done off-chain, Tessa 6. So all this is done in like JavaScript instead of Solidity. So again, if our profit is greater than the past most profitable position we found for this particular market, like DAI, Uniswap, ETH, SushiSwap, then we create this structure called best crossed market and add it there to record like, here's the best combination that we found for this thing. And by looping through our different types of markets and our different sizes, you can return that object to help us to then trade on. Again, doing volume in this way is kind of naive, and it actually won't make you profit because someone will always be able to price things in a better way. But there's a great paper that you should read and try to figure out on your own that will help you price things in an optimal way. It's written by a couple different folks that you probably know from Twitter. And it lays out the problem of how Uniswap works and why, and it gives you like a mathematical framework to reason about the price of Uniswap, how it relates to its reserves, and how you can actually find the optimal arbitrage. So how you can set up the mathematical problem such that you can get the amount in to give to a certain combination of pairs to get the maximal amount out. And they don't give you that like just as is. So they won't tell you that in a lot of granularity. But if you wanted to, you could think about this in particular and derive the mathematical equation for yourself to get that optimal arbitrage. And then there's something in the appendix as well that will help you with that, if I recall correctly. Yeah, so you want to take this maximization function and like implement it for the specific case of trading between two different Uniswap V2 pairs, and then solve it for the optimal amount in to maximize your function. And I won't leak any more alpha about this. Yeah, this is a fun problem for you all to get through. So, all right, we have returned a bunch of markets with the tokens and the optimal amount for us to trade on them. So we know for a given market, I put in this amount and I get a certain amount out. And given the reserves that we got earlier, we know that that's profitable. That's like the evaluation logic of any searcher that you'll have. We went and we got all this data, we structured it in the right way, and then we go through and we evaluate each of them. Again, we're doing all of this off chain. We don't want to do any of this on chain. Please don't. It will pain me if you do this. I will physically be hurt if you do this on chain because it's gas inefficient. So you first get data, then we apply some evaluation logic to it to understand what our parameters would be to execute it on chain. And now we have those parameters. So we are about ready to make a trade, you all. And it is this section here that you're looking at in the console log. So this we're printing each of our different cross markets with the profit and the volume down here, along with what the tokens are. And we return to our arbitrage function and to now capture these and execute some Flashbots bundles and some arbitrage, make some money. We pass in our best cross market structure here, which again tells us like how much to trade on what pairs and what our expected profit is. And we generate some console logging about this that you see down here somewhere. Yep, so send this much WETH, and that's in way, so like token speak or whatever. I think this says 2 ETH actually, 2 times 10 to the 18th. And you expect to get 3.5 ETH in return. And then I'll like run you through what these are either. And another very useful trick when interacting with these things is you don't actually always implement the function that you want to interact with directly on chain. And instead, you generate the bytecode for what interacting with that function with a certain set of parameters would look like. And you only pass that bytecode in on chain. And so in our case, these payloads are the bytecode for executing certain parameters on chain, like buying a certain amount of asset on a certain Uniswap pair. So this bytecode right here is like for our like scam token earlier, albeit, of a profit of 3.5 ETH with volume 2. On the first pair, I want to buy 2 ETH worth of this token. And then the second thing in the payload array is, now that I have these tokens, I'm going to sell them for 5.5 ETH and make the 3.5 profit. So this buy calls thing right here is generating that bytecode data because it's like easier to interact with pairs in that way instead of directly implementing that interaction on chain. Although you could do that too. Scott, maybe you can talk about like what the advantage is of using this payloads and target method is over like implementing a pair swap directly in a smart contract. Like, why did you make this design?
Sure. So there's a couple reasons. One is that this is very kind of uniquely enabled by Flashbots. Before Flashbots, you would submit a transaction and you don't really know what block it's going to land in. You don't really know where in the block it's going to land in. And so what happens is in a normal arbitrage that didn't use Flashbots, you have, hey, here's what a pair looks like. I need to like wake up. I need to like see what the reserves are right now because they could have changed between when I created this transaction and when it landed. I need to do that calculation because I don't know what those values are. But with Flashbots, because you target blocks and you always land at the head of the block, you have this just massive optimization where you're like, I already checked this in my code. I already know what the reserves are. I don't need to ask those questions on chain. And so the gas savings that you can get from kind of just constructing off chain, just the exact payloads means that not only does this like save just an absolute ton of storage reads that you don't need to do, it also means that you can upgrade this contract to use brand new brand new exchanges and not even upgrade your contract, because all you need to do is pass in new targets with new call data, because it doesn't even know that it's talking to Uniswap. It just knows if I send this contract these bytes, I'm going to go from this much assets to that much assets. So it's ultimately flexible, very, very cheap, and very enabled by the way the Flashbots works.
Amazing. That was an excellent and succinct answer. So thank you. I didn't even think about like the storage reads that you would do if you're not interacting directly with this. But yeah, it physically pains me. Like, I'm not even joking. I cringe whenever I see a bot that like gets the reserves when they're using Flashbot bundles, because I know they're less efficient than they could be. They could be making more money and winning more. So yeah, this stuff gets input into our smart contract. I guess it's like the right time to look at that, where this is actually executed. We saw the monitoring smart contract already, but let's look at the bundle executor smart contract. So we, in our arbitrage, where did that go? So we've gotten these calls of buying and selling things. And our targets here, where to point these calls, these pieces of data, go to, that is a good question, Bombardier, and I will get to that in just a moment. So we have like this data for a function that we're going to point it at something, but we need to know where to point it. So we point it at our targets here, and our targets are ordered as our payloads are. So our first target is the first pair, corresponds to the first payload. Second target, second pair, second payload, right? It's one of our inputs here. And we plug that into our contract here under targets and payloads, in addition to some other parameters like how much we pay the miner and how much we're trading with. And we first like sanity check. Before we do anything, are our targets and our payloads the same length? If not, you messed up. Not sure like where, but somewhere you messed up. Not really sure how you do that, but. And then we look at what our balance was before. This is super useful in order to make sure that we made profit here. And we optimistically transfer our ETH to the first pair. So we interact directly with WETH here. You go to the first target, so our first pair, and this is the volume that we're going in here, right? So this answers your question, Bombardier. Do you need approvals? And the answer is no. You don't need approvals because of a nuance of how Uniswap v2 works. So in Uniswap v2, if you look at the actual code for a swap, I think it's called swap, if I recall. Yeah. If you actually go into the code for the swap, there's no approval. It doesn't take any ETH from you. It just assumes that ETH is sent to the contract, and then it performs some calculations in order to make sure that the amount of ETH that you are asking for it out makes sense. So it's a little bit weird of a flow, but you send ETH to it, and then you ask it for a certain amount of ETH out. And the contract assumes that you've done this, and it'll check to make sure that like the amounts that you're getting out make sense and don't break the x times y is equal to k constant function. And this actually has some gas savings as well, so it's very nice not needing to do approvals. It saves you the gas of doing that. And we, in fact, are calling the low-level swap function here, which is what our payloads are. So we transfer ETH to the first market, and then we start looping through our different targets here and start calling our target. We can go to the first pair, call it with this first payload, which is basically, I want to buy this amount of asset and I want to get out this amount. And our payload is like some information for this swap function here. So actually our payload says like I want X amount of amount 0 out. I want Y amount of the other token out. I want it to go to this address And then we never really touch this parameter. It's useful for flash loans and nothing else. So I'm just going to like say ignore this parameter. You won't need it, at least in the simple arbitrage repo. That's what our payload is. It's just like parameters that go into these in this function. And so we're calling at some address in our target address that function with whatever the parameters are in our payloads. And we make sure that it's successful and we get a response if we want. We have a require, so all of our like swaps need to be successful. And that's actually where the swaps happen in our trades here. So if you went, you looked at a trade on Uniswap, someone arbitraging these things, this is the line where the swaps actually happen after all that stuff off chain. Yeah, sorry, David, I'm like trying to record. I'm not entirely certain whether or not I'm recording or not. Maybe Twitch has like a native recurring recording thing. And then after our swaps have happened, we just make sure that we didn't get wrecked somehow, that our balance of our contract in WETH is greater than what it started. So before we did any of the swaps, we got the balance of WETH, and then after we did our swaps, we got it after. And then we just have this very simple requirement. Our balance after needs to be higher than our balance before, plus the amount that we pay to the miner. So that's like overall profit. If we're not paying anything to the miner, I'm not sure why. If you're using Flashbots, you'll never get in, but nonetheless, if you're not, then we return, we're done here. If we are paying something to the miner, then we need to make sure that we have enough ETH in order to call this very special function to the miner that pays them. So we're getting like the right amount of ETH here, making sure that we have it. And this is super important for Flashbots, so pay attention, you all. Normally, when you send transactions, not through Flashbots bundles, you need to pay fees to the miner for including your transaction through gas fees. So 10 gwei, it's like what you see on MetaMask, something like that. Through Flashbots and bundles and our special client, Ethereum client called MEV-Geth, you have the ability to pay the miner through a smart contract call called block.coinbase.transfer. And this enables like a lot of super interesting things. In particular, in this code, our block.coinbase.transfer happens after our requirement that our balance of WETH is greater than it started. Okay? So we make sure that we've made profit here, and then after that, we pay the miner through block.coinbase.transfer ETH amount to Coinbase. Right? And what this means is that if this condition that our ETH after is not greater than before, plus Coinbase transfer, then we won't pay the miner anything. They'll get 0. And since they get 0 amount of ETH, the miner has no incentive to include our bundle. So the miner will only get paid if we are profitable. And since they're only paid if we're profitable, the miner only has an incentive to include our bundle if we make profit, and everything goes as expected. And then you could do a bunch of other fun things here. So like if some other condition is not equal to true, then return, or you can change the amount of Coinbase accordingly, like else if some random state is not equal to whatever, then change the amount of Coinbase that you're paying. So being able to dynamically change the amounts you're paying and require that you're successful in order to pay the miner some fees is extremely powerful. And I suggest that you leverage it very much so. So that is actually the smart contract where we're actually arbitraging markets and interacting with them and executing our trades. That is most of it, folks. Oh, I should also see how you, not the fountain of youth. For some reason, I just look older in my picture. Everybody says I look like 45. I'm 25. That drawing of me just makes me look really old. I don't really understand. It looks young to me. But thank you, Gibbs. I appreciate it. I think, question mark. But so our last thing here is like we have our transaction. Instead of just sending it normally, we're going to get the details of the transaction so we can send it in a different way. Yeah, I'm trying to record this, everybody. I'm not really sure how to do that. And a couple people have told me, but I don't have Twitch Studio. I'm using OBS. So there's like a, let me see this. Yeah, I'm recording on my local OBS. Not sure if Twitch will record it as well. Someone eat this bro for Twitch Studio. I didn't know that was a thing, so let me see. Really, I'll get back to the code in just a moment, but I will try to record this really quick. Yeah, so I'm not using a stream key. I'm just using OBS, and I connected my Twitch account and I hit start streaming, so I don't really know what else to do there. Should be under settings and streams. Nope, not there, folks. Well, my promise to you all is that if I don't have this recorded, at some other point in the future, I will do more of these. Sorry, I'm not good at Twitch. But, well, I do have record now on OBS. But, yeah. I wasn't doing that the whole time, though. That's the unfortunate thing. I'm going to return to this now. So, sorry, everybody. Now we have our transaction, and you just saw how we would execute it on chain with our contracts and whatnot. Instead of just sending it on, we populate the details of it, and we're going to send it in a special way. So in a Flashbots bundle, particularly. So this is like sanity check right here. We estimate the gas of our transaction, and a lot of the times, if Alex Dunn, I will answer your question on latency. I see it, and I will address it, but let me get through this. So a lot of the times, if you simulate a transaction with estimate gas and it fails, that means that your transaction was going to fail for whatever reason. You don't really know why, but like estimating something, and if it fails to estimate gas, most of the time you should just discard it and put it away and say like, I'll get the next one. So we try to estimate our gas here, and if it does not work, then we just throw away our transaction. And we have like another guard for it being like weirdly large in case we get wrecked for some reason. Like if someone was using us to print a bunch of chai tokens or something. But if our gas estimation succeeds, that means our transaction probably will as well, if it landed on chain. And we go on to create a bundle. So Flashbots bundles look like this. You have like an array of transactions, including the signer of the transaction and your transaction details. And then we, if you had a more advanced transaction, you could just sequence a bunch of stuff like this. So this is our first transaction number 1, but like maybe you want transaction number 2, and transaction number 3. This is super cool, extremely useful for unique opportunities and like things that you can't do in the normal mempool. And in particular, bundles and all these transactions need to be executed all or nothing, and all in the order that they are. So you could take some action with this first transaction and then immediately follow it up with some action with this second transaction, followed up with the third as well. And precisely, Bombardier, you're right. If I had a signed transaction I could plug that in here. I don't even need to make the transactions myself. I can just go to the mempool and I can get a transaction and plug it in like this. And again, like, it doesn't need to be mine. I can just pick a transaction out of the mempool and plug it in here. And like, for example, maybe an Oracle update or something like that, where you're trying to backrun it, be the first to liquidate someone else. So you put the signed transaction in your bundle, and then the follow-up is liquidating the Oracle update. So this is super, super useful. And the entire transaction, you want the signed transaction. So it's like the RLP encoded transaction. I don't really know what that means. I just know that you need a transaction that has been signed by some Ethereum key, which is, you can get that from the mempool. Yep. So, okay, we've created our bundle here. We're almost done, and then I'll let you all ask questions. And yes, you are right, Marty Joe. This is how they snipe liquidity events on the same block that they're deployed. So for our sanity, we console log the bundle, which is actually like what this looks like here. This is a bundle with our signer and the transaction data. Flashbots takes signed bundles to authenticate. So we sign the bundle with some private key. You saw that earlier. And we simulate the bundle of the Flashbots relay to make sure we're not just sending junk to it. So you simulate it. The Flashbots relay will return the simulation with some information about it, like how much gas it used, if there were any errors, how much it paid to the miner. And if there was no error, then we continue and we actually send the bundle. And one thing here that is important is we're sending our bundle not just for the next block, but 2 blocks into the future. Because sometimes miners mine blocks really quickly. So if a block is mined in like a second, you want your bundle to be there and be valid for 2 blocks into the future. So it could get executed then in addition to the next block. That's why we send both here. Okay, that is all of the simple arbitrage repo. Thank you all for like sticking in through. This is like a long stream now, over an hour. Scott, if you're around and you have anything to add to that, feel free to. Otherwise, we can like take some questions. And there's one that I keep on putting off.
No, I just want to say that this is, it was named simple arbitrage really to highlight that it is extremely naive in many, many aspects. This is really not going to make you probably anything because many people run it and it's just not a very optimal way to perform arbitrage. So it should serve as a framework to build, your own bots that have novel methods of extracting MEV and maybe serve as a good example of that, and not really something that you're going to get up and start printing money.
And please don't put money in it and expect us to help you if you don't know what to do. It's like a big burden whenever that happens. So please understand what you're doing if you throw a lot of money into this. Sorry to interrupt you, Scott.
No, it was otherwise really great. I appreciate the presentation. I learned something about my own code.
Did you? What did you learn? You wrote this code.
I forgot how it all like fit together. It was a different time.
Yeah, it was like 6 months ago for you. So. Mm-hmm. Yeah, I was figuring that out on the run. It's been a while since I like read simple arbitrage or ran it myself. So, yeah, let's take some let's take some questions, you all. So there was one question earlier that was on whether latency mattered. The answer is kind of. So there's a block that's like every 14 seconds, right? And that means on average every 14 seconds. But sometimes blocks are much quicker than that. Could happen in 1 second or even quicker. And if your bundle is there within that 1 second on like the very short end of block times, you could be the only person that is competing for an opportunity. This is a major alpha leak. I don't think all searchers know this, but fuck it, I'll tell you the alpha leak, whatever. So if you are really quick and on the short end of the block distribution, say you can get a bundle there in a second, you can underpay comparative to what you would pay later in the block, or in like the block time distribution. So at 7 seconds in, everyone else that's running simple arbitrage will have their bundles in and they'll be competing with you. But at 1 second in, you're going to be like the only person that has a bundle in, and you'll have no competition. And because you have no competition, that means you can pay way less for the same opportunity. And so the optimal strategy is actually to pay very little if you're very quick, and then up your bid after that over time. So alpha leak there. Latency sort of matters on some things, but you can win. It really depends on what you're doing, and like you can underprice things if you're really fast. I think that's why latency matters, and you win a couple things. Hope that made sense. A9800 says, so if the block time is less than 7 seconds, you win. What the point I'm trying to make is like, the longer the block goes on, the more opportunity there is for other people to submit opportunities. And that means other people will probably be bidding higher amounts. And if you can submit an opportunity in a really quick way, then you don't have to be competing in the auction with them. You may be the only bid in the auction, so to speak. So 1 second in, you might pay 20% of your profits, and 7 seconds in, you might have to pay 95%. And those aren't exaggerations either. Okay, so what sort of timeframes should one allow to become proficient at that? So at this sort of stuff, depends on your starting point. But I feel like if you already know Solidity and Node.js, then I'd give yourself like 3 months, something like that, to try to write a new searcher and make profit. If you're really dedicated to doing this, like. But that would be writing completely new searchers and making profit in new strategies. Yeah, I don't really have a good answer for that. Scott, do you have any opinion? Like, how long should someone give themselves for a learning curve before they stop?
I mean, you should never stop, never give up. Yeah, I think that's good. I mean, you could probably get. I would probably just start with like fake MEV first. If you can land some like fake MEV where you just like pay the miner, 0.001 for nothing, and then go from there to see if you can find some small little arbitrage, maybe based on simple arbitrage, but maybe try to optimize. I think you can get there probably. I mean, it's probably take a few months. There's just lots of weird little edge cases. One of the best ways that I've found is that the Discord we have for Flashbots has a hashtag searchers. And there's just like lots of people very open about their experience and where they're at, and people from all different skill levels. I think it's a really great place to, even learn about alpha. People talk about new things in there and be like, oh, I'll try this, it's a really small thing. Maybe it's not worth other people's time, but it's a great learning opportunity to like extract, 0.01 per block or something.
Yeah. Tons of alpha leaks there. An unbelievable amount.
Yeah.
So let's see. Drew's Apple question, is it possible to deploy a bundle executor inside of the bundle? Yes, it's very cool. It's like Virgin ETH, because you can start your searcher without having any ETH. You can use the profit from some opportunity to deploy a contract, the transaction before. It's like kind of mind bending. But because a bundle is executed in a sequence and all or nothing, you could deploy your contract in the first transaction and then execute an arbitrage opportunity in the second. And actually, this fellow on Twitter called MEV Alpha Leak, I had him in my bar. MEV Alpha Leak did this. They are this bot operator. I hope you're tuning in. I love your content and your contract on chain. But they're this bot operator that deployed their contract in a bundle and then arbitraged it within the same bundle without having any ETH in their contracts. It's super, super cool to do that. So yeah, you can definitely do that. Somebody asks, I'm sorry, I can't pronounce your name. Regarding this naive code, is modifying naive assumptions enough to be at least effective with this bot? I think you might catch some things if you got your pricing strategy better. So this part where we're just doing, I'm gonna close this as well. This part where we're just looking at different volumes and like running through each of them. If you could figure out the optimal amount of ether to put in, then I think you would have a much better chance of landing stuff on chain and making a profit. And yeah, you'd probably have to bid pretty high in order to make that work, but I think you could get in some transactions like this. You won't make a lot.
I think so. I think that's I agree that's the biggest problem. The other thing is that it doesn't do multi-token hops. It's really just, A to B, B to A. And so you're not going to find that many of those because most of the best ones are going to be multi-hop, but it's not gas inefficient. So you're not going to lose on gas inefficiency. So any A to B, B to A, I think you could be competitive.
Yeah. So figure out how to do A to B, B to A in an optimal way, and then implement multiple markets. And that will be a little bit more efficient. So A98,000 asks, do you resend the bundle with higher Coinbase transfer? That was like the earlier thing about the auction and latency. Yeah, you would. So that's how you like rebid. Rory OC, I think that's how you pronounce your name. I don't know. Asks if I could submit something live. I don't have a contract that's set up to do that. But I can like run this code, and that does everything except for submit. So this will run in the background and it'll do everything except for submit, but I don't have the contract set up, unfortunately. So let's see, where would the flash loan be at the high level? Oh, you asked the right questions. So I actually, in the very, 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 very early days of Flashbots, like January, I think, I made a pull request that you can find here. Yeah, January 18th, I added a flash loan to this thing. And you can look at my code here for how that works. But in short, everything is the same and how you actually execute stuff, except you need to call Aave and get a flash loan in the way that they expect. So you pass in data through this params object. Then you ask Aave for the flash loan. Here, Aave calls back your contract on this execute operation function. So right here you have your ETH, and then you're able to execute the same parameter basically as before of swapping on particular pairs with the parameters done through payloads like before. So then it's the same. That's how the flash loan version works. And we're coming out, I should also say, that we are gonna update this repo slightly and deploy a flash loan version that anyone can interact with. So you won't need to deploy your own contract. You won't need to have any ETH. You can just run this repo and point it at our smart contract, and you'll get profits in your account, actually, which is pretty cool. But yeah, all those caveats about this being naive and there like being better ways.
But I will say what the nice thing about it though is because it uses that really low level target plus call data, you could even modify it to include V3 capabilities, and you could integrate V3 just by modifying client side code and not even having to redeploy a new contract.
And so the only thing is you would need to look at V3 and see whether this WETH transfer is still applicable, right?
Yeah, I think that V3 might be a bad example. I think that might not actually be possible because I think that V3 always requires a callback. But any other, you could implement anything in there you wanted to.
So yeah, I've like
V3 maybe
personally used essentially this code with a little bit of alteration to transfer like first Uniswap V2 and then Curve second, or Balance or something like that. those two I know are possible. So you could edit this, yeah, to Scott's point, to like look at different markets and use the same contract to do that. All right. I'm getting to the chat here, you all. So I'm sorry, kind of slow. What's my take on flash loans? Probably too gas expensive, and you will not be competitive, but it's a good way to get started. Somebody says DYDX flash loans are cheaper than Aave. That is right, in that they are cheaper in fees if you're moving in size. Aave flash loans are cheaper in gas. So if you want to take out small flash loans, use Aave. If you're taking out large ones, use DYDX. And that is right. Alex?
The other aspect is because this is Uniswap v2, I think there's actually like nearly free flash loans kind of just built into doing any swap on v2. So that could be something to consider for your own modifications, is just relying on the v2 built-in bytes call data.
Oh yeah, that's a good idea. Yeah. Yeah, I don't know how that would work though. But so you can figure that out. I think that idea like makes a lot of sense to me. Please open a PR if you figure that out. Contribute back. We'd love to see it. Oh, and like in the background here, I am trying to submit bundles and failing because I don't have a contract deployed. But this is actually what it looks like when you're running in production. Maybe I'll just like pull this up. You all can see it. Somebody asks, is there a way to make a sandwich bot suffer from an uncle block? Yes, there is. That is too much alpha, and I'm not going to tell you how to attack other searchers, unfortunately. You have to figure that out. Jay says, you mentioned the public GitHub repo in your ETH Global talk. I don't know what the time frame is on that. I need to clean it up, and it seems like the synthetics people may actually go ahead with that liquidation opportunity, in which case like I'll make money from it, and I don't really want to hand that money on a platter for other people to take from me. So at least I hope I will. So whenever the opportunity passes, I'll open source it. I thought that it was no longer available. It apparently still is, and I just like showed everybody my code, which is unfortunate. Yeah, so David O. Bentley says, can we try these MEV ARBs on testnet, other chains? Is there an ETH buy-in? You can test it on Goerli. So Uniswap v2 exists on Goerli, as does Flashbots. So you can send bundles there. Maybe like a little bit weird trading on v2, but you could create artificial ARBs on Goerli if you wanted to and test it there. So I think that's like Pedro Dinero says, you mean multiple hops, not multiple markets? Yeah, so we mean both of those things. So could you go from like ETH to DAI to USDC back to ETH, as opposed to just ETH, DAI, ETH? That's one thing. And then you could also trade like Uniswap to Curve to Balancer to Uniswap, something like that. A Red Hawk, yep, the repo is open, but the other one is not. You're gonna need to integrate v3 yourself, unfortunately, Zen. So Foster FM Moster says something about whether collusion between searchers plays in the success of an ARB strategy. I'd say when there's a small amount of people that are all going for the same things, then definitely. For this code, what you're looking at, probably not, because there are so many different people running it, you're not gonna be able to get into contact with them. And so there's no real way to collude with. But there are relatively few people who submit v3 ARBs. And as such, if you can find all those v3 people, you can actually collude with them. But since the v2 ARBs are like much more difficult, collusion actually makes sense there. So only if there's a small amount of people on your strategies. Tessa, all swaps in V2 are flash swaps. I don't know if all swaps are, Drew. That's a good question. I don't know. If your bundle is using too little gas, how would you increase the usage? It's like a weird question because there's like very few things that you would legitimately do that get under that limit. It's kind of weird, but if you really wanted to, you could just split your Coinbase payment into like 10 things. So I could show you how to do that. So yeah, here in the block.coinbase.transfer, instead of doing it once, you could do it like 2 times. Or you could just do something where your bundle consumed more gas. I think most of the time when people complain about that, they're like, stuff is actually broken, and they're not submitting anything that makes sense because there's like very little where that does make sense. I hate. Kasha says, can you use Suganodi? I don't know what that is. So no idea what you're talking about, but the answer is like maybe. Sugandis. Oh, I got wrecked. You're right. There you go. Wouldn't be proper Twitch without me getting wrecked. Tweet about it. Get your clout. I'm sure. So any other questions, folks? Otherwise, I will wrap up. I honestly didn't even read what you're saying. A 98,000. Yeah, Alex, you're totally right. So before Flashbots, when Oracle updates were sent, they'd be sent with like super low. Now my friends are laughing at me in the background, so thanks, Kasha. But before Flashbots, Oracle updates were sent with super low gas prices, and you'd just be like super annoyed because your thing is about to be liquidated. You need the Oracle update to go through, or you're about to liquidate something, you need the Oracle update to go through, and you just sort of had to wait for the low gas price Oracle updates. But you are right that now, if you wanted to, you could find an Oracle update, include it in your bundle, and then submit that through. Yeah. And essentially like subsidize their gas to get it in earlier. Or you could like include it in your bundle and then liquidate a loan or something like that. So, all right. Anything else, you all? And it's fine, Kasha. I understand why you needed to wreck me. Thanks for joining, David. Sure, I'll try to do this more. It's kind of fun. I think next time I'll be quicker. I spent a lot of time here at length explaining this stuff. So next time I'll try to take less time up. Marty Joe asks, is sniping listing something that is supported by Flashbots? We do not discriminate against what people do on our platform. So we're permissionless. You can use Flashbots for anything, including token snipings if you want, or like wrecking other bots. There's some things that are like I won't encourage you to do, but I can't stop you. So if you want to go like snipe the latest token and for whatever reason, like go for it. I can't stop you. Nobody can. I hope you make a lot of money. Jay Jonah says using flash loans are not as profitable with Flashbots because of extra gas costs. Yeah, so it doesn't necessarily have anything to do with Flashbots. It's rather like you will not win as much because of the extra gas cost. So the gas price of your bundle will be lower because you have more gas. Because your bundle gas price is lower, that means other people will win more often. You need to be more competitive by raising your gas price higher. I will try. I will try saving this Red Hawk. Yeah. It would be very nice if this like hour and 40 minutes of a walkthrough would be saved somewhere. So I don't really want to go through this repo again for 2 hours. And then I could just point people to this. But I'm not sure whether it was saved or not because I don't have Twitch Studio or whatever. Yeah. And yeah, of course, like thanks to Scott as well for jumping in at very late notice, also with other people around. So that was amazing. He actually wrote this repo. Lady Gaga Little Monster asks, is that contract deployed? And by that contract, I think you mean the like Uniswap monitoring one. The answer is it is deployed, and anybody can use it. So I'll go to it. You can see. Yep, it's here. It's on Etherscan. It's in the repo. You can like go find it and whatever. All right, folks. I will take one more round of questions and then I will end. Kasha, we're not gonna let you wreck us anymore. Any more hints on how to make the bundle more competitive in terms of gas? I think that you need to I think being very good at Solidity helps, and then understanding what data you can do off chain and then what data you need to do on chain, and like thinking very hard about that. Doing everything you can off chain, then learning Solidity optimizations. That also helps. And the very advanced stuff you can get all the way down in the EVM. But in order to like have basic strategies, if you're not competing for the V3 arbs, I think you'll be fine without getting down to the level of the EVM. Yeah, so Lady Gaga Little Monster says, can you also explain again why using a contract? This is my last question too. Scott knows. He picked up on that. I got wrecked. But Lady Gaga Little Monster says, can you explain again why using a contract to query data is faster than doing it locally? The reason is that if you are just interacting directly with a pair, you need to make many different queries to your node. So if I wanted to get 40,000 pairs on Uniswap, which is what you're doing when you run the script, then I need to make 40,000 different requests to my node. And that means I make a request, my node needs to like make sense of my requests and then run it locally, do some computation, return that, and then pass it back to me. And each stage there incurs some cost of time. And like in particular, it takes time on the networking layer to return stuff to me, and it takes time to make sense of the JSON RPC requests as well, like what happens when you interact with your node. And if you instead can make one giant request that gets all the data that you want, then you don't need to incur the cost of like making n different requests to your node and the time that it takes to like make sense of the JSON RPC there. And then you also don't need to incur the cost of like returning the data and the networking time that it takes to get the data back to you. So instead of making n number of requests and then incurring those costs n times in terms of time, you can make one giant request that gets your n different sets of data, and it just like makes it way faster, an order of magnitude quicker.
I have another one for you. You might find interesting about the reason to batch your lookups.
Oh, yeah.
So it is faster. There's like latency, for all the reasons you stated. The other one is that if you are doing something like looking at the reserves for two different pairs, if you ask those as two different RPC calls, you could be getting results from two different blocks. Whereas if you make the query inside of like a multi-lookup on chain, you are definitely getting consistent state returns to you from at least the perspective of one block.
That's good. Yeah, I didn't think about that. Yeah. That is kind of interesting. I didn't think about that before. I guess that does happen fairly. Oh, and then you're always synchronized on your code. Like all of your reserves for everything is always synchronized, as opposed to having like one on one reserve, or one on block 1, another reserve is on block 2, another reserve is on block 3. It could get like very messy with lots of reserves very quick.
Yeah.
So any other advice you want to give to searchers, Scott? Anything else? Like last thoughts?
No, I don't think so. I mean, I think that searchers definitely make the most money when they work together. I mean, the miners need to be paid for the services, but let's not bid each other up to 99.99% right away. And come over to Discord #searchers. It's actually a really, really cool place to talk to other people that maybe you're meeting on chain, or maybe that people are more surprisingly helpful, even when there's money at stake. I think is probably one of the most fascinating discoveries from starting Flashbots, is just how open people are with their alpha. I mean, even Bert today talking about like the timing, this timing escalation. I don't know. It's the love of the game,
We do it for the clout. That's why we do it.
Well,
Clout.
Yeah. I don't want money. I want Twitter followers.
My whole game is just monetizing and turning other people's alpha into my Twitter followers. So you leak alpha in MEV searchers, or our searchers channel, I will post it on Twitter and I'll get the cloud. So, all right, folks. I think that is it. Thank you again, Scott, so much for jumping on and riffing on this repo, all the advice. And thank you to the couple people that tuned in. And thank you, I hope, to Twitch for recording this. I hope I can just post this on YouTube. So thanks, everybody. I will catch you all another time. I'm gonna stop recording now. Until next time, see you on chain.